Assalamualaikum and hi. This is our group which is Nurul Alia binti Nur Hisham, Siti Nur Shifa binti Subeki, Nur Fatin binti Muhammad Razali, and Wardina Safia binti Jamaluddin. In this video, we will discuss the introduction, description of the content, real-life application, example of past year question, and finally a summary. Next, I'm going to introduction. What is logic? By harnessing the power of mathematical logic, specifically through the application of syllogism and propositional logic, legal information undergoes systematic organization and analysis when coupled with the principle of discrete mathematics. The use of mathematical logic and discrete mathematics aims to enhance the accuracy and predictability of legal decisions, providing a formal foundation for a more rigorous and organized legal framework. Next, we proceed to the description of the content. Description graph theory is the study of a relationship between objects. This object can be represented as dots, like the landmasses above, and their relationship as lines, like the bridges. The dots are called vertices or node, and the lines are called edges or links. The connection of all the vertices and edges together is called a graph and can be represented as an image, like the ones below.
Okay, next I will explain about application used in real life. First, you can apply with a street. When you want to go somewhere, and you do not want to walk too much, you need to enter through a bridge and exit from a different bridge, and finding the geometry and relationship, and from that, you will get the closest way to reach your destination. Okay, next, airline scheduling flow problems. Uh, in this situation, airline can create a direct graph, so the vertices and a directed edge will link the departure, and airline can then calculate the minimum flow that covers all vertices. So the airline will not crash with each other. Next, direction in a map, shortest path. Uh, you can transform a map into a graph, so all street intersections are considered as vertices, and the streets that connect intersections as edges. And you can calculate the path, or the website will calculate the path with the lowest sum of edges widths between the two corresponding. Okay, this is example application used in real life, which is street. The point with an orange color is the place we want to go to, and as you can see, there are various alternative routes that we can take, either far or near, to get to that place. So it's up to you which route you want to use, either far or near. So next I will pass to Shifa.
Okay, next let's go through the past year question that related to our chapter 4, which is directed graph. So this is the example of past year question. Given a graph G as shown in figure 2. So the question have given you a graph in figure 2. So the first question will be state the size of the graph. So the question asks you to state the size of the graph. Okay, the answer is 8. The size of the graph is 8. Why it is 8? Okay, let's see here. You must remember that the size of the graph is equivalent to the total number of nodes in the graph. So here I already count it to you guys. You could count it one by one. A, B, C, D, E, F, G, H. Okay, total is 8. So that's why the answer previously is 8. Okay. Okay, the next question is give an example of Hamiltonian path and justify your answer if the path is not exist. As you know, Hamiltonian path only allowed to visit each vertex 1. Okay, let's figure out if there's a graph S exists Hamiltonian path in it. Can the graph visit each vertex only once? As we see here, yes, it exists since it will go through each vertex only once. If you can see C, A, B, D, E, F, E, G, H, they can go through each vertex only once. So the answer is Amazon F just exists since it can go through each vertex once. Give your reason since the question asks you to justify your answer. Next question, give an example of invariant path and justify your answer if the path does not exist. Okay, as we know, invariant path exists if it passes each edge exactly once, and the degree of each vertex must be odd number, and minimum have two of them, two of odd number minimum. So let's see. Let's check each vertex degree first. Okay, let's check. A, because we can see here A have 2 degree, B have 2, D have 5, which is odd number, C have 2, E have 2, F have 4, G have 2, and H have 2. So based on this graph here, we could see there only one odd degree, which is at the node D. So it doesn't satisfy the condition to be invariant path. So the answer here is the invariant path does not exist because it only have one vertex of odd degree. Give your reason since the question asks you to justify. Don't forget that. Next question is give an example of invariant circuit and justify your answer if the circuit does not exist. Okay, invariant circuit maybe exist if it passes each edge exactly once and the degree of each vertex must be even numbered. Remember that. So from the previous question, we have already written the degree of each node. So here we could see that the D is an even number that will automatically will turn the graph on will automatically see that invariant circuit is not exist because they have the odd degree here. Since invariant circuit have all of them to be even number. Okay, so the answer here there is no invariant circuit slightly in the graph above because not they have an odd degree. Okay, now the last question give an example of spanning tree rooted at node F with height 2. Okay, so the question one is to start with node F with height 2. The height must be 2. So you have to figure it out. Not F, height 2. Okay, so it must start with F. Start with F, height 2. Okay, so start with F. F can be connected to G. F can be connected to H. F can be connected to E. So this is correct. And then E can be connected to D. So this is also correct. Okay, and D can be connected to B. D can be connected to A, and D can be connected to C. So this is also correct. Also, the height of this tree is 2. That fulfill the requirement of the question previously. So this is the correct one to draw a tree. Here, okay. Okay, that's all from me and the past question that we answered until here. Yay, it's all done. Okay, the total mark that you will achieve here is 7 marks. So it's really easy to achieve this mark. So make sure you get a full mark here.
Summary for Chapter 4. The first one is Directed Graph Basic, second Node Degrees in Directed Graph, and last Application of Directed Graph. The first one is Directed Graph Basics. Node connected by directed edges, highlighting one-way relationships, fundamental for modeling system with directional dependencies. The second is node degrees in directed graph. In degree and out degree matrix reveal node relationships.
Next will be
Analyzing
S2
these
fighting.
measures provides insights into information flow and network structure. The last is applications of directed graph, widely applied in fields like social networks and project management, offering a powerful tool for modeling and analyzing complex relationships.